Good morning, good afternoon, and good evening to everyone who joins us from around the world. We're so glad you're here. This is Andrew and Renee. Welcome to the Stacks series. Today we are exploring alchemy.
Oh, wow. A topic that I think it suffers from perhaps the most severe case of bad PR in the history of science.
I think that's putting it lightly. I have to admit, when I saw this on the docket, my brain immediately went to a very specific, almost cliche place.
Let me guess, a dark room.
A dark room, yeah. I'm picturing a guy with a long white beard, maybe pointy hat with stars on it.
A bubbling flask of something green.
Exactly. A bubbling green goo, a skull on the desk, and he's frantically trying to turn a lump of lead into a bar of gold.
The whole sorcerer trope. It's powerful.
It's very powerful. It feels like magic. It feels like something out of a fantasy novel, not a serious subject. It just has this aura of being the fool's quest. But after going through the research, I think I owe the past a pretty big apology.
You might. Because while that wizard image, it exists for a reason, the reality is so much more substantial. If we just dismiss alchemy as, failed magic, we're missing the story.
What are we missing?
We're missing a sophisticated, global, proto-scientific discipline that spanned over 2,500 years.
2,500? I mean, that's just a massive chunk of human history to be just messing around with rocks.
Precisely. This wasn't a few eccentrics in their basements. For millennia, this was the primary intellectual framework for the smartest people on the planet.
Wow.
Alchemy is the DNA of modern chemistry. It's the direct ancestor of pharmacology. And as we'll get into, it even birthed key concepts in modern psychology.
So it's not just about turning lead into gold.
Not even close. It was humanity's first serious, sustained attempt to physically manipulate the world in order to understand the divine.
Okay, so our mission today is to, strip away the wizard robes and look at the actual science or proto-science underneath all that?
That's the plan. We're going to trace the story of how we moved from the black mud of the Nile River all the way to the periodic table of elements.
I love that. Okay, let's start where we always do. Section 1. Foundations. What we think we know versus what was actually going on. And the word itself, alchemy, seems like the perfect place to start because its history is like a collection of passport stamps.
It really is. If you trace the word, you're literally tracing the movement of knowledge across continents.
So in English, it comes from Arabic, al-kīmiyā.
That's right.
And the al is the, right? Like in algebra or alcohol.
Correct. The Arabic definite article. But the kēmeia part, that's where the historians really start to argue and where it gets truly fascinating.
Okay.
Most scholars will trace it back to the Greek word chēmeia.
Chēmeia. What did that mean?
It was a pretty practical term. It meant the art of alloying metals, of casting or fusing them together. Metalworking, essentially.
So very hands-on.
Very hands-on. But there's a deeper root, a much older root, that really anchors this entire discipline in ancient Egypt.
And this is the part that completely shifted my perspective.
I think it does for most people. The theory is that chēmeia itself comes from the ancient Egyptian word kēme, or sometimes written as kēme.
And what does kēme mean?
It literally means the black earth.
The black earth, that's incredibly evocative. Break that down for us. Why the black earth?
Okay, so picture the geography of ancient Egypt. What's the one thing that defines the entire civilization?
The Nile.
The Nile River. And for thousands of years, every single year, the Nile would flood its banks.
Yep.
It was this massive, predictable cataclysm.
Right.
But when those floodwaters receded, they left behind this thick, rich, dark, incredibly fertile sludge, a black mud.
The source of all life.
The source of everything. It's where all the crops grew. It was
Right.
the black land, kēme. And everything else, the desert just beyond the floodplain, was the red land, sterile, dead sand, where nothing grew.
So, to the Egyptians, this black earth, this mud, it was the physical substance of creation itself.
Exactly. It was the ultimate mystery. How does life emerge from this dark, inert soil? So, alchemy doesn't originally mean the art of gold making.
It means the Egyptian art.
Or the art of the black earth. It grounds the entire practice not in greed, but in fertility, in the great cosmic cycles of life, death, and regeneration.
That is so much more profound.
It is. But just to make things a little more complicated, there's another competing theory.
Of course there is.
And this one connects the word all the way over to China.
Really? I didn't realize the word itself might have traveled that far east.
Well, the ideas certainly did. There's a term in the Fukienese dialect of China, chinai.
Okay, chinai. What's that?
It translates roughly to gold juice.
Gold juice. That sounds a little unappetizing and very expensive.
Slabs. Well, it wasn't something you'd pick up at the market. It referred to a liquid elixir, something you drink for longevity. The theory is that as traders moved along the Silk Road, carrying ideas along with their goods, the term chēmeia could have been heard and corrupted into kēmeia by Arabic speakers.
So even in the name, we have this collision of cultures: Arabic, Greek, Egyptian, maybe even Chinese.
Right from the very beginning.
Right.
And that really sets the stage for how this knowledge developed. It wasn't one single origin point. We see these crucibles of knowledge rising, often independently, in different parts of the world.
And the first great melting pot was Hellenistic Egypt.
Specifically, the city of Alexandria.
Alexandria. It's always Alexandria, isn't it? It feels like the intellectual capital of the ancient world.
It really was the Silicon Valley of its time. Around, say, 300 CE, you have this incredible convergence happening there.
What's converging?
You've got the native Egyptian artisans on one side. These are the engineers. They have thousands of years of practical generational knowledge. They know how to embalm bodies, which is incredibly complex chemistry.
Right. Preserving tissue.
They know how to dye fabrics, vibrant colors, how to make glass, how to work with gold, copper, lead. They're the people who actually know how to do things.
Hands-on experts.
Yes. But then, into this city, you have the arrival of Greek philosophy. And the Greek philosophers, they don't really care about making a nice blue pigment for a vase.
They care about the big questions.
The biggest questions. What is blue? What is matter? What is the fundamental nature of the universe? They have these abstract, high-minded theories about the elements in the cosmos.
So alchemy is what happens when the workshop meets the university.
That's a perfect way to put it. It is the marriage of practical craft and theoretical philosophy.
And out of that marriage, we get some really interesting characters. Like Zosimos of Panopolis. I read some of the excerpts you sent from his writings, and I have to say, the man was intense.
Intense is a very polite word for it. Zosimos is one of the very first alchemists to actually write his processes down in detail. But reading him is like reading a fever dream.
It's not a chemistry textbook.
Not at all. He'll mix a detailed description of a piece of lab equipment, like a furnace or a beaker, with these wild, Gnostic, mystical visions.
Yeah, I remember he talks about priests sacrificing themselves and bodies being boiled in water until the skin peels off and the flesh dissolves. It reads like a horror movie script.
And that's the key. It's all symbolism. Zosimos was a Gnostic Christian. He believed the physical world, the body, was a trap. It was corrupt, heavy, dead.
A prison for the soul.
A prison for the spirit.
Yeah.
And to liberate the spirit, you had to destroy the body. He applied that exact same theology to his metals.
So when he looked at a lump of lead, he wasn't just seeing a metal.
No. To him, a piece of lead was a fallen soul trapped in a dead body. It was heavy, dark, corrupt.
And gold.
Gold was the perfect spiritual metal. It was the resurrected body. So to save the lead, to transmute it into gold, you had to first torture it. You had to kill its body.
So you burn it, you dissolve it in acid, you boil it.
You're performing a ritual of death and resurrection on the metal to release its pure golden spirit.
That is such a critical distinction. They weren't just cooking rocks to get rich. It was a religious rite performed in a laboratory.
As above, so below. That was the central maxim. What happens to the soul in heaven happens to the metal on earth.
But not everyone was so mystical?
No, not at all. And we have to talk about someone who I truly believe is one of the great unsung heroes of science, a woman named Mary.
Mary the Jewess, or sometimes called Maria Prophetessa.
Yes, she lived around 200 CE, probably in North Africa. And unlike Zosimos, who was all visions and abstraction, Mary was a practical inventor. She was arguably the first true experimental chemist.
And her legacy is sitting in the kitchens of probably half the people listening right now.
It absolutely is. If you've ever needed to melt chocolate for a cake or make a very delicate hollandaise sauce and you didn't want to burn it, what did you use?
A double boiler.
Which is known in French and in scientific labs to this day as the bain Marie.
Mary's bath.
She invented it 1,800 years ago.
Okay, pause there. Why would an alchemist need a double boiler? I'm assuming she wasn't making cheese fondue.
She was not. She needed it because direct fire is a violent, chaotic force. If you put a glass flask directly on an open flame, the temperature can spike, the glass can shatter, the delicate chemicals inside might burn or evaporate too quickly.
It's too aggressive.
Far too aggressive. Mary realized that to nurture the spirit of the metal, to gently coax it through its transformations, she needed a gentle, constant, predictable heat.
Almost like an incubator.
Precisely. She wanted to mimic the gentle warmth of the earth or even the warmth of a womb, where things grow slowly. So she used the steam from boiling water to gently heat her primary vessel. That is brilliant practical engineering.
And she invented other things too, right?
She did. She invented the tribicose, which was a type of distillation apparatus with 3 arms, allowing her to collect 3 different distillates at once. She was isolating substances, separating liquids based on their boiling points. She was doing real repeatable chemistry.
It's amazing. A tool we use for making dessert was invented to simulate the womb of the earth for transmuting metals. It shows how practical this all was.
It does. But now, let's pan the camera across the world to China. Because at the same time Mary and Zosimos are working in Alexandria, a completely different alchemical tradition is flourishing. And its motivation was totally different.
How so? It wasn't about gold?
It really wasn't about wealth. In the West, even with all the mysticism, there was always that undertone of, hey, if I figure this out, I'm going to be fabulously wealthy.
Right.
In China, which was deeply influenced by Taoist philosophy, the focus was almost entirely on time.
They wanted to stop the clock.
They wanted immortality. The Taoists believed that nature operated according to a rhythm, the Tao, and if you could perfectly align yourself with it, you could transcend death. They were searching for the elixir of life.
And this search split into 2 different schools of thought, right?
It did. Weiden and Neiden.
Let's break those down. Weiden is the external alchemy.
Yes. This is the one that looks more like what we'd recognize as alchemy. It's lab work. It's the idea that you can physically brew a potion that will grant eternal life.
Okay, and what were they putting in this potion?
They looked at materials in nature that seemed eternal or had powerful life force. Gold never rusts or tarnishes.
It's incorruptible.
Exactly. Jade is incredibly tough and was associated with purity. Cinnabar, a bright red mineral, looks like blood, the very essence of life.
The logic makes a kind of sense. You are what you eat. If I can consume the forever thing, I will become the forever thing.
The logic is sound, but the chemistry was fatal.
Why?
Because the main ingredient in many of these elixirs, the one they prized the most, was cinnabar.
And for anyone who doesn't know their geology, cinnabar is mercury ore.
It's mercury sulfide. It is profoundly toxic.
So they were drinking mercury cocktails to try and live forever.
Tragically, yes. We have historical records of several Chinese emperors who became obsessed with these elixirs. They would start taking them, and the court records describe symptoms that are just classic heavy metal poisoning.
Like what?
They become manic, then paranoid. They'd have vivid hallucinations.
Which they probably interpreted as, it's working, I'm having spiritual visions.
That's exactly what they thought. They thought they were communing with the immortals, and then their kidneys would fail and they would die. It's this heartbreaking irony. The supposed cure for death was actually a fast pass to the grave.
And I'm guessing that catastrophic failure rate is what led to the second school, Needham?
Internal alchemy, yes. People started to realize that maybe drinking liquid mercury wasn't the best long-term health strategy, so they moved the laboratory inside the human body.
Okay, this sounds more like something we would recognize today as meditation or maybe qigong.
It is. The body becomes the furnace. Your breath becomes the bellows. The chemicals are your own internal energies, your cog. The goal was to use meditation and breathing techniques to circulate this life force through the body to create the golden elixir within your own soul.
That distinction is so fascinating. One school is trying to hack the external world, the other is trying to hack the self.
And just to complete the global picture, we have to briefly touch on India and the Rasiana tradition.
And let me guess, Mercury shows up again.
Mercury is the star of the show.
What is it about that specific element? Why did it fascinate everyone, from Alexandria to China to India?
Have you ever seen liquid mercury in person?
Only in videos. It's that shimmering silver liquid that moves like it's alive.
It looks magical. It defies categories. It's a metal. It's incredibly heavy, but it flows like water. It's a solid and a liquid at the same time. It feels like a living spirit.
Okay.
In the Indian Rasiana tradition, they viewed mercury as the literal seminal essence of the god Shiva. They called it rasa.
So it wasn't just a chemical. It was a piece of a god.
Precisely. They believed that through a complex process of purification, cooking it with sulfur and various herbs over many cycles, they could render it safe to consume. And by consuming it, you were integrating the divine body into your own, achieving a kind of divine health and longevity.
So we've got these independent fires burning brightly in Egypt, China, and India. How do we get from there to the European wizard in the castle image? How did this knowledge make its way west?
The bridge. The crucial bridge was the Islamic Golden Age.
Right. When the Roman Empire collapsed and Europe entered the so-called Dark Ages, the lights didn't go out everywhere.
Not at all. In places like Baghdad in the 8th and 9th centuries, the lights were blazing. The Abbasid caliphs in Baghdad funded a massive project called the Translation Movement.
They became the guardians of knowledge?
They did. They systematically translated all the important Greek, Persian, and Indian texts on medicine, astronomy, mathematics, and alchemy into Arabic. And this is where we meet an absolute giant of the field, a man named Jabir ibn Hayyan.
Known in the West as Gibber.
Jabir is often called the father of chemistry, and I think he really earns that title. He took the, frankly, chaotic mess of mystical texts from Alexandria, the Zosimo stuff, and he systematized it. He brought logic and order to the chaos.
How do you do that?
He set up a real functioning laboratory. He insisted on experimentation, and he invented or perfected the hardware that would define alchemy for the next 1,000 years. Most importantly, the alembic.
The alembic, that's the iconic teardrop shape we see in all the drawings, right?
Oh, that's the one. Picture a round-bottom flask where you boil your liquid, but the genius is the lid, the cap that sits on top. It's a dome with a tube that slopes downward off to one side.
The beak?
The beak, exactly.
Oh.
The vapor from your boiling liquid rises, hits the cool surface of the dome, condenses back into droplets, and then runs down the beak into a separate collection vessel. This is distillation.
Explain why distillation was such a revolutionary technology.
Before the alembic, if you wanted to separate things, you could maybe filter them through cloth or let them settle out of water, but you couldn't effectively separate two mixed liquids.
Okay.
With the alembic, you could capture the spirit of a substance. You could boil wine and capture the pure alcohol that boiled off first. You could distill flowers and capture their essential oils for perfume. And, most importantly for chemistry, you could make mineral acids.
I want to double-click on the acids because the research really emphasized this as a massive turning point. Why was creating a strong acid so important?
Imagine you're an ancient craftsman. The strongest acid you have access to is vinegar. Acetic acid, you can clean a tarnished coin with it, maybe pickle some vegetables. That's about it.
It's pretty weak.
Very weak. Jabir and the Islamic alchemists who followed him figured out how to distill minerals like vitriol and saltpeter to create sulfuric acid and nitric acid.
And these are the heavy hitters.
These are the game changers. Sulfuric acid will eat through most metals. Nitric acid will dissolve silver completely. Imagine seeing that for the first time in history.
It must have looked like pure sorcery.
Think about it. You have a solid piece of silver. You drop it into this clear, innocent-looking liquid, and the silver just vanishes. It hisses, it bubbles, it gives off this acrid red smoke, and then it's gone.
It would have confirmed their entire worldview.
Absolutely. If a liquid can make a solid metal disappear or change its form so dramatically, then of course transmutation must be possible. If I can dissolve it, surely I can find a way to put it back together as gold.
That brings us perfectly to the theoretical framework, because this is where modern listeners, I think, get stuck. We know lead is element 82 on the periodic table. Gold is 79. You can't just cook one into the other without a nuclear reactor.
Right.
But they didn't know about protons or atomic numbers, so what was their logic? Why did they believe this was not only possible, but inevitable?
They were all running on the Aristotelian operating system. They believed that everything in the physical universe was composed of just 4 fundamental elements: earth, water, air, and fire.
The classic.
The classics. But here is the crucial part that we often misunderstand. Don't think of those elements as physical building blocks, like Legos. Think of them as qualities or states of being.
Okay, what do you mean by qualities?
Each element was a combination of 2 of 4 primary qualities: hot, cold, wet, and dry. So earth was the combination of cold and dry. Water was cold and wet. Air was hot and wet. And fire was hot and dry.
It's like a sliding scale.
Exactly. And because it's a sliding scale, you can move between them. Transmutation wasn't a strange idea. They saw it happen every single day.
Give me an example.
Take a pot of water. Water is cold and wet. Now, you put that pot on a fire. What are you doing? You are adding the quality of heat.
Okay.
You are changing the quality from cold to hot. So you're changing cold and wet to hot and wet. And what happens to the water?
It boils and turns into steam.
Which they consider to be air. You have physically transmuted the element of water into the element of air just by adding heat.
When you put it that way, it's not crazy at all. It's actually very logical, observational science. They just had the wrong underlying physics.
Precisely. So they applied that logic to metals. They thought metals are just different combinations of these same elements and qualities. If I can just figure out how to change the qualities, how to dry out the lead or heat up the mercury in the right way, I can change the metal itself.
So lead wasn't a fundamentally different thing from gold.
No, they believe metals grew in the earth like plants. Lead was just unripe gold. It was metal that hadn't finished cooking in the warmth of the earth yet.
And the alchemist's job was just to speed up Mother Nature's process, to bake the bread faster.
You've got it. That was the goal, to perfect what nature had started.
And then, later on, a new layer gets added to this theory. The tria prima.
The 3 primes, introduced by Paracelsus. This was a new way of looking at matter. He said everything was composed of 3 essential principles: mercury, sulfur, and salt.
But again, he didn't mean the actual chemical mercury or a lump of salt.
No, these were philosophical principles. Mercury represented the spirit of a thing, its volatility, its fluidity, the part that flies away as vapor when you heat it. It was the feminine principle.
Okay.
Sulfur represented the soul. That's its combustibility, its oiliness, its consciousness or identity. The part that burns. This was the male principle.
And salt.
Salt was the body, the solid, earthy part that resists the fire. The ash that's left behind after you burn something.
So every single thing, a piece of wood, a piece of metal, a human being, has a body, a soul, and a spirit.
And the alchemist's job, the great work, was to take a substance, chemically separate these 3 principles, purify each one individually, and then recombine them in a new, perfect, incorruptible ratio.
And of course, you couldn't do any of this without looking up at the stars.
As above, so below. You couldn't be an alchemist without also being an astrologer. They believed the 7 known metals grew in the earth under the direct influence of the 7 known celestial bodies.
So gold is the sun. It's yellow, it's perfect.
Right. Silver is the moon. Iron, which is reddish and used for weapons, is Mars, the god of war.
Copper is Venus.
Yes. And lead, which is heavy, dull, and associated with old age and death, is Saturn. Tin is Jupiter. And mercury, the metal, is of course linked to the planet Mercury.
So if you're going to try to turn lead into gold, you better check the astrological charts to see what Saturn and the sun are doing.
You absolutely have to. It was a holistic science. You couldn't just mix chemicals in a flask. You had to be in tune with the entire cosmos, your own spiritual state, the time of day, the phase of the moon, the position of the planets. It all mattered.
It's a beautiful, intricate system. It connects everything. But obviously, as we move forward in history, cracks start to form in this worldview.
It cracks.
Which brings us perfectly to our second section, the active debate. Because eventually someone comes along and says, hey, maybe this obsession with making gold is missing the point.
Enter Paracelsus.
I love this guy. From the research, he sounds like the ultimate rock star of the 16th century. Just a complete character.
He was the ultimate disruptor. His full name was Philippus Aurelius Theophrastus Bombastus von Hohenheim.
You can't make that up. Bombastus. It fits.
It really does. He gave himself the name Paracelsus, which means greater than Celsus. Celsus was a very famous Roman medical writer.
So he's literally walking around calling himself better than the best doctor.
That is some serious confidence. He was arrogant, he was brilliant, he wandered all over Europe, and he loved to make a statement.
And the biggest statement of all was when he started his new job as a professor.
At the University of Basel. Instead of starting his first lecture by reading from the classic texts of Galen and Avicenna, the pillars of medicine,
He built a bonfire.
he built a bonfire in the town square with some students and publicly burned their books.
That is a massive gesture. I mean, Galen's work was the undisputed medical Bible for over 1,000 years. Burning his books is like a physics professor today burning Einstein's papers.
He was declaring a revolution. He famously told his students, "The buckles on my shoes know more medicine than these old authors." He wanted to fundamentally shift the entire purpose of alchemy.
Away from chrysopoeia gold making.
And towards iatrochemistry.
Iatrochemistry. Let's unpack that. That translates to chemical medicine.
Yes. Before Paracelsus, European medicine was dominated by the humoral theory of the ancient Greeks. The idea that your body contained 4 fluids, or humors: blood, phlegm, yellow bile, and black bile.
And if you were sick, it was just because those fluids were out of balance.
Exactly. So the cure was to rebalance them. They would bleed you to reduce your blood, or give you gentle herbs to make you vomit to get rid of bile. It was all about reestablishing equilibrium.
Paracelsus said that was all wrong.
He said, no, the body isn't a bag of fluids. The body is a chemical system. And diseases aren't just internal imbalances. They are specific external invaders. They are like seeds of poison that take root in the body.
And to kill a specific invader,
You need a specific weapon. You need chemistry. He introduced the radical idea of treating diseases with powerful minerals and metals. He used mercury, arsenic, antimony.
which sounds terrifying. He was intentionally feeding people poison.
It was incredibly dangerous. But he operated on a principle that is now the foundation of all toxicology. His most famous maxim, sola dosis facit venenum.
The dose makes the poison.
Exactly. Anything can be toxic if you take too much. Oxygen is toxic at high pressure. Water is toxic if you drink gallons and gallons of it. But arsenic, in a tiny, carefully calculated microdose, might just kill the syphilis spirituae without killing the patient.
So he's basically the grandfather of modern pharmacology, chemotherapy, antibiotics, the whole idea of taking a targeted poison to kill a disease. That starts here.
It really does. But you can imagine the firestorm it caused. The traditional Galenic doctors called him a murderer and a madman. His followers called him a prophet who was curing the incurable. It was the reformation of matter.
And this really leads us into the 17th century, into this murky, overlapping period that historians now call chemistry, with a Y.
Yes, chemistry with a Y is the term we use now to describe this transition period where alchemy and chemistry hasn't fully separated yet. It wasn't a clean break. You didn't have alchemy end on Tuesday and chemistry begin on Wednesday.
And nothing illustrates that blurry line better than Isaac Newton.
Newton is the ultimate example. We think of him as the epitome of the rational scientist. Gravity, calculus, optics, the first modern physicist.
Right, the guy with the apple.
But the reality is much weirder. When historians finally gained access to his private papers, they found that he wrote over 1 million words on alchemy.
1 million words, that's more than he wrote on physics, isn't it?
Much more. He was obsessed. He wasn't just doing science. He was on a mystical quest. He was hunting for the prisca sapientia, the ancient wisdom. It was the belief that the ancient sages, the Egyptians, the Greeks, had known all the secrets of the universe, but they'd hidden them in codes, in myths, and symbols to protect the knowledge from the unworthy.
So he thought the story of Jason and the Golden Fleece wasn't just a myth.
He thought it was a coded chemical recipe for making the Philosopher's Stone. He spent countless nights in his secret laboratory at Cambridge, breathing in toxic mercury fumes, trying to replicate these ancient experiments.
And this wasn't separate from his physics, it was connected.
It was deeply connected. And this is the part that just blows my mind. He believed that if he could unlock the secrets of alchemical transformation, he could finally understand gravity.
Wait, how on earth does gravity connect to alchemy?
Think about it from his perspective. Newton figured out the mathematics of gravity perfectly. He could predict the orbits of the planets. But he had absolutely no idea what gravity was.
The mechanism.
The mechanism. How does the sun reach out and pull the Earth across millions of miles of empty space? It made no rational sense. It was action at a distance.
It sounds like magic.
Newton thought so too. It was the biggest hole in his own theory. So he privately hypothesized that there might be a vegetative spirit, a kind of hidden, living, active alchemical principle that permeated the entire universe, connecting all matter. He was looking for a magical explanation for a physical force.
The father of modern physics was looking for magic. That is incredible.
It just shows that the history of science is messy and complicated, and his contemporary, Robert Boyle, is just as complex.
Boyle's law, pressure and volume of a gas. He's called the father of modern chemistry. He even wrote a famous book called The Skeptical Chemist.
Which sounds like a total takedown of alchemy.
Right.
But it's not. It's really an attack on bad alchemy, on the frauds and the mystics. Boyle himself was a practicing alchemist. He believed in transmutation and spent years trying to make gold. But he introduced a crucial idea that paved the way for modern chemistry.
The corpuscular theory.
Yes. He argued that matter wasn't made of philosophical principles like earth, air, fire, and water. It was made of tiny physical particles, corpuscles, that clustered together in different arrangements.
So an early version of atomic theory.
Exactly. And if you could just figure out how to break down those clusters and rearrange them, you could change one substance into another. He was using alchemical logic to arrive at a fundamentally chemical truth.
So if Newton and Boyle, the giants of the scientific revolution, were both alchemists, how did the split finally happen? Why do we now have chemistry as a legitimate science and alchemy as a dusty old magical practice?
It really came down to a fundamental shift in culture and communication. The new scientific revolution, driven by organizations like the Royal Society in London, championed a new core value: transparency.
Publish or perish.
Right. Alchemists were, by their very nature, secretive. They wrote in elaborate codes and allegories. Take the green lion and let him devour the sun. If you didn't have the secret decoder ring, it was just gibberish.
In fact, doesn't the word gibberish come from Geber, from Jabir ibn Hayyan?
That's one of the leading theories, yes. Because his Arabic texts, when translated into Latin, were so dense and difficult to understand.
That's a great fact.
But the new scientists said, no more secrets. You must write down your methods clearly. You have to explain your experiment in such a way that anyone, anywhere can repeat it and get the same results.
Repeatability, reproducibility.
That's the bedrock of modern science. And that demand for clarity killed the mysticism.
Oh.
In 1718, a French chemist named Étienne François Geoffroy published something called the affinity tables. It was a simple chart. And instead of using symbols like dragons and kings getting married, it just showed substance A reacts with substance B. Substance C will displace substance A from the compound.
He visualized chemical reactions as predictable laws of nature, not as mystical love affairs between metals.
He made it boring. He made it predictable. He made it chemistry. And once it's predictable, once the magic evaporates under the bright light of public scrutiny, it's no longer alchemy.
But this brings us to our third section, frontiers. We didn't just throw everything away. We didn't burn down the alchemist's lab. We kept a huge inheritance from them.
We kept almost all of the hardware. I mean, walk into any high-tech chemistry lab today. What do you see?
Flasks, beakers, test tubes, crucibles.
The retort, the condenser. These are all alchemical tools, refined over centuries. The processes we still use, distillation, sublimation, crystallization, filtration, were all perfected by alchemists. They literally taught us how to manipulate matter.
And we also inherited some specific discoveries that changed the world. Let's talk about phosphorus, because this story is, well, it's pretty gross, but it's also amazing.
It's one of my favorite stories in the history of science. Hennig Brand, 1669, in Hamburg, Germany.
Set the scene for us.
Brand was a merchant who had gone bankrupt. He married a wealthy woman and decided to use her money to fund his new passion, alchemy. He was convinced, like many, that he could find the philosopher's stone.
And he thought the secret was hidden in the human body.
Specifically, in urine.
Why urine? Because it's a gold-colored liquid.
That was the logic. A golden liquid from the golden animal, man. He thought, there must be some essence of gold in there. So he decided to distill it, to concentrate its essence.
How much urine are we talking about here?
The records say he collected about 1,500 gallons.
1,500 gallons. Where does a person even get that much?
He paid soldiers from the local barracks. He collected it from his neighbors. He let it all sit in vats in his cellar until it putrefied.
Ugh. So it rotted.
It rotted and reeked of ammonia. Then he boiled this massive quantity down to a thick, syrupy paste, and then he distilled the vapors from that paste at an extremely high temperature.
The smell must have been apocalyptic.
I can't even imagine. His neighbors must have loved him. But one night, after hours of heating this vile substance, he looked at the collection vessel of his apparatus, and he saw something incredible.
What did he see?
A waxy white substance had collected there. It was glowing in the dark with a cold, eerie greenish light.
He hadn't found gold.
No. He had discovered phosphorus. The name comes from the Greek for light bringer. He had discovered a brand new chemical element. It was the first time in recorded history that a human being had isolated an element that wasn't known to the ancients.
And he found it in waste. He literally turned pee into light.
Talk about transmutation. It became a sensation. Kings and nobles traveled from all over Europe to see the cold fire. And that discovery eventually led to the invention of matches, fertilizers, and even explosives.
Then there's the story of porcelain.
White gold. In the early 1700s, Europe was completely obsessed with Chinese porcelain. They couldn't figure out the secret to making it. It was more valuable than silver. Kings would go bankrupt buying tiny little vases.
And along comes an alchemist named Johann Friedrich Butker.
Butker was a young, brash alchemist in Prussia who claimed he knew the secret to making gold. Word got out, and the King of Poland, Augustus the Strong, had him arrested.
And locked in a dungeon.
Locked in a dungeon laboratory with a simple command: make me gold or you will die.
Standard operating procedure for kings back then, I guess?
Pretty much. Butker, of course, couldn't make gold. He was terrified for his life. But working with a scientist named Schönhaus, he started experimenting with different kinds of clay at very high temperatures. And eventually, he figured it out.
The secret formula?
The secret formula for true hard paste porcelain using a specific type of clay called kaolin. He invented Meissen porcelain, the first in Europe.
So he saved his own life, not by making actual gold, but by making weight gold.
Exactly. It launched a massive industry that made millions for the king, an alchemical failure that became a huge economic success.
And we can't forget maybe the most popular alchemical product of all time, alcohol.
The word itself is pure alchemy. It comes from the Arabic al-kūl.
Al-kūl.
Originally, it referred to a very fine powder, like the kohl eyeliner used in the Middle East. But over time, the meaning shifted to mean the refined spirit or the pure essence of any substance.
So when we talk about spirits of wine,
We are using a literal alchemical term. When alchemists first learned to distill wine, they believed they were extracting its very soul. That clear, burning, volatile liquid was the aqua vitae,
the water of life.
the water of life. They thought it was a panacea, a cure-all, a key to longevity.
Well, on a Friday night, some people still treat it that way.
Indeed. But it just shows how deeply embedded this history is in our daily lives. We were using alchemical words and drinking alchemical discoveries.
So the physical science, the chemistry, it moved on and became chemistry. But alchemy as an idea, it didn't die, it just migrated.
It moved from the laboratory into the mind.
And this brings us to the 20th century and a very unlikely figure, Carl Jung.
The famous Swiss psychologist, one of Freud's students.
What did a modern psychologist see in these bizarre ancient texts about green lions and red dragons?
Jung was at a point in his career where he was struggling to understand the deep symbolic language of the unconscious mind, the language of dreams. He started reading these old alchemical texts, which are, let's be honest, incredibly confusing and surreal. But he had an epiphany.
What was the epiphany?
He realized the alchemists weren't just describing chemical processes. They couldn't have been. The texts were too weird, too illogical for that. He realized they were projecting their own internal psychological states onto the matter in their flasks.
The flask was a mirror.
The flask was a mirror of the soul. They were, without realizing it, describing the process of psychological transformation, the journeys of the self.
So when they talked about the first stage of the great work, the blackening, the nigredo,
Jung saw that as a perfect metaphor for depression, the dark night of the soul, the confrontation with your own shadow, the breaking down of the ego. You have to dissolve and putrefy before you can be reborn.
and the next stage, the albedo, the whitening.
That's purification, clarity, insight. It's washing away the dirt and the darkness to see the pure underlying truth of yourself.
And the final stage, the rubedo, the reddening.
That's wholeness, integration, the union of the conscious and the unconscious, the masculine and the feminine within. That's the achievement of the Philosopher's Stone.
So to Jung, the stone wasn't a physical rock that makes gold.
The Philosopher's Stone was the fully realized, integrated, whole human being. The great work wasn't about perfecting metal, it was about perfecting the soul.
That's profound. It implies that alchemy was never really about the metals at all, or at least not only about the metals.
It was always dual. As above, so below. As in the flask, so in the soul.
So let's bring this into our final section, implications. Why does any of this matter to us today, besides the fact that we use their beakers and drink their spirits?
I think the most relevant and frankly chilling implication is what we could call the alchemist's dilemma, the ethics of transmutation.
Explain that.
Alchemists were, as we said, notoriously secretive. Why? Part of it was protecting trade secrets, but there was a deeper ethical reason. They genuinely believed that if the secret of the Philosopher's Stone, the key to infinite wealth and infinite life, fell into the wrong hands, it would destroy the world.
It's the ultimate disruptive technology.
Imagine if a greedy, foolish king could suddenly turn a mountain of lead into a mountain of gold. What happens to the economy?
It completely collapses, gold becomes worthless, all trade, all society built on it falls apart.
Exactly. And now look at where we are today. We are the new alchemists. We are on the verge of creating technologies that offer seemingly infinite power and transformation.
You're talking about AI, genetic engineering.
Artificial intelligence.
Yeah.
CRISPR gene editing. Nuclear fusion. Nuclear fission is literal modern alchemy. We are transmuting uranium into other elements and releasing incredible amounts of energy.
And we have the exact same fear.
We have the exact same fear. The alchemist asked, is humanity wise enough? Is it morally mature enough to handle this kind of power? We are asking that same question about AI every single day. We hold a power that could save our civilization or completely destroy it.
That gives me chills. The green lion devouring the sun is now the atom smasher.
It really is. The symbolism is still just as potent.
So finally, let me ask the big question. With all this said, Was alchemy a failure?
That is the failed science fallacy, and I absolutely hate it.
Make the case. Defend alchemy.
If you judge a fish by its ability to climb a tree, it will live its whole life believing it's a failure. If you judge alchemy only by its stated goal of making infinite physical gold bars, then, okay, in that narrow sense, it failed. But look at everything else it did do.
It taught us that matter can be changed.
Yes. That sounds simple to us, but it was revolutionary. It broke the static Aristotelian idea that forms are fixed and eternal. It taught us that with fire and acid and intelligence, you can transform the world around you.
It taught us to experiment.
The entire empirical method, the idea of trial and error, of careful observation, of learning from your mistakes, was born in the soot and smoke of the alchemist's furnace.
In iatrochemistry.
This, to me, is the big one. They searched for the elixir of life. They wanted a single magic potion that would make us immortal. They didn't find that.
Yeah.
But by shifting the entire paradigm of medicine away from just balancing humors and towards targeted chemical intervention, they created the philosophical foundation for all of modern medicine.
And because of modern medicine.
We have doubled the average human lifespan in the last few centuries. In the Middle Ages, you were lucky to live to 40. Now, we routinely live to 80 and beyond. In a very real, practical way, they succeeded beyond their wildest dreams. They found the secret to extending human life.
So the Philosopher's Stone wasn't a stone at all.
It came in the form of penicillin. It came in the form of vaccines and sanitation and chemotherapy. They found it. It just didn't look like they thought it would.
That's a fantastic way to frame it. They aimed for the stars, missed, and ended up landing on the moon. Before we wrap up, I do want to leave our listeners with one final thought. We've talked about the Philosopher's Stone as this mythical object to be found, but there's a strong tradition in alchemy that the stone was never something you found in a flask. It was something you became.
The great work was always internal.
If alchemy is truly the art of transformation, of purification, of perfecting, then we are all, in our own lives, alchemists. We're all starting with the lead of our bad habits, our ignorance, our fears, and we are constantly trying to transmute that base material into the gold of wisdom, compassion, and understanding.
And that process never ends. It's a lifelong great work.
Before we wrap up, thank you to all our partners, sponsors, and scholars who made this podcast and the research possible. We're truly grateful for your support.
And to our listeners, thank you for being part of this journey with us. If you enjoyed today's episode, be sure to subscribe and follow Stack Studios for more informative content and support us in Patreon.
Until next time, stay curious, keep learning, and let the search for wisdom guide you forward. Have a great day.